Hey all, welcome to ShareTrek. This is Raj here. I'm your host today. As always, when we look at a therapy in this channel, we dig into how it works and try to understand the concept. Today, on the demand from multiple viewers, I'm going to interrupt my Viv coverage and do a segment on ConsvX Vaccine today, and we'll resume the Viv from the next video onwards. In a subsequent video, I will trace the current status of clinical trials for the ConsvX vaccine. That said, let's get started. Welcome back, friends. In the relentless pursuit of an effective HIV vaccine, researchers are exploring innovative strategies to combat the vast array of HIV-1 variants that are circulating in populations worldwide. One promising initiative focuses on harnessing the power of CD8 T-cell responses by utilizing a bivalent Mosaic vaccine targeting 11 well-defined epitopes from highly conserved regions of the HIV. Traditionally, HIV's remarkable adaptability and its ability to escape immune responses have posed significant challenges. In response, researchers propose a strategy that shifts the focus towards vulnerable sites of HIV-1 displaying the least entropy among global isolates. This involves using algorithms to design vaccine cocktails featuring optimized complementing sequences. Before we proceed, I'd like to make a request to support the channel. Hey all, this is Raj here. Thanks for supporting the channel so far by becoming subscribers and viewers of our videos. If you're not yet subscribed, press the subscribe button now. This is the right time. And to help me grow further with this channel, I would request that you consider becoming a member. And in order to make it easy for you, I'm introducing a new membership level at just 10 cents per day or $2.99 for the month. It's just like giving me a cup of coffee once in a while. Wouldn't you like to do that? Please check out our membership section and become a member today. It'll really help me progress this channel further and give me a sense of accomplishment. Look forward to see you at the membership section. I'll catch up with you again. Bye for now. Welcome back. The Mosaic vaccine is at the heart of this initiative, and it's a bivalent Mosaic vaccine designed to present a mosaic of epitopes from highly conserved HIV ConsvX regions. The rationale is to slow and control HIV-1 by directing killer T cells, particularly CD8 plus T cells, towards the most conserved and therefore vulnerable regions of the virus. This approach, in theory, limits the virus's ability to mutate in response to immune pressure. Let me take a moment to elaborate on this. HIV virus keeps on mutating basically because it's using the human transcriptase function, and therefore it's not perfectly compatible with HIV, so there's a whole lot of mutations. And as a result of which we have different strains of HIV virus. There are all minor variations, major variations, and so on. But one of the benefits of this kind of mutation for HIV virus is that if we target any part of the HIV virus, HIV is able to evade because the mutations which change that part of the HIV virus that we are targeting manages to thrive, and as a result, a therapy goes waste because the therapy is no longer effective against HIV. But there are certain parts of HIV which do not mutate that much. And the reason being that if those parts mutate, then HIV is not able to propagate further. So these are parts which are very, very essential for either building the viral shell or for getting entry into the CD4 T cell. So those are the kind of conserved areas which are responsible for very, very specific functions, and they cannot be changed. So when you look at a ConsvX vaccine, we are talking about targeting the conserved areas of the virus, and this could typically be GAG protein, POL, and things like that, but we won't go into those details. Suffice to understand that the Mosaic talks about taking pieces of peptides or proteins from those conserved regions, building them together into a mosaic and using them to train the CD8 and CD4 T cells in our body in order to target those patterns wherever they are present. And if an actual HIV virus comes in, it may have one of those mosaic patterns, and the CD8 and CD4 T cell will be absolutely prepared to attack and destroy the HIV virus when it enters into the body. So that's the general approach. Now, having said that, the vaccine employs a sophisticated delivery system utilizing two different viral vectors. The first one is a simian adenovirus ChAd0x1, and the second one is a pox virus MVA. This bivalent prime boost strategy aims to enhance the immune response. The adenovirus primes the immune system and the pox virus acts as a booster, together presenting a comprehensive immunogenic profile to induce robust CD8 T cell responses. The initiative has its roots in the acknowledgement that conventional vaccine strategies have fallen short in controlling HIV-1. The research journey involved the development and testing of prototype conserved region T cell vaccines such as HIV ConsvX, which demonstrated promising results in clinical trials. The subsequent second generation HIV ConsvX vaccines refined the approach, incorporating algorithm redefined conserved regions and computed mutually complementing Mosaic 1 and Mosaic 2 immunogens. The Mosaic 1 immunogen will go into the adenovirus and the Mosaic 2 will go into the pox virus. The vaccines underwent extensive testing in animal models, showcasing encouraging induction of CD4 plus and CD8 plus T cell responses. As the initiative progressed, a phase 3 efficacy trial was launched to test vaccines with mosaics of full-length GAG, POL, and ENV proteins, marking a significant step towards real-world applications. In conclusions, I will say that the ongoing research into bivalent mosaic vaccine represents a beacon of hope in the quest to develop an effective HIV vaccine. By targeting strategically conserved regions and employing a bivalent prime boost strategy, this initiative aims to elicit robust and broad CD8 T cell responses, holding the potential to offer a global solution to the HIV-1 pandemic. As the journey continues, the prospect of transformative vaccine remains on the horizon, bringing renewed optimism to the field of HIV vaccine research. And I'm going to look further into what happened to this particular vaccine. In the past, I have made mosaic vaccine videos where we spoke about how they failed. And I want to do a little more study into this ConsvX vaccine to confirm that it is still active and if it is still in a viable clinical trial. So I'll be doing a little more search, come back to you with a separate video on the current status of the clinical trials on this vaccine, where all it is being tested and whether it's still ongoing and what is the due date when we can expect some confirmatory data from such clinical trials. With that, my friends, I would like to bring this video to an end. Please do not hesitate to put your comments. It helps the channel algorithms. Please do not hesitate to put a like out there if you like this video. These are all free things that you could do in order to help the channel. And you can go a step further and help this channel by checking out our basic membership, which costs just 10 cents per day. And it will help this channel a big deal. Just for $2.99 per month, you get early release videos of HIV in this channel, and you will be helping this channel continue bringing these kind of deeply researched videos to you. With that, my friends, I'd like to bring this video to an end. Thanks and have a great day. Bye for now.